Second method for solving equations, 1 and 2 step, is through modeling. So modeling, you're going to draw a depiction of the equation and then use that to help you solve it. So I'm going to give you an example here. So let's say it's 2n equals 10. Okay, so our textbook uses cups and counters. Now it's going to use a cup because we can't see inside of a cup to know how many. So this is my bad drawing of a cup. So I don't know how many are in there, counters. So on this one, I know that there's 10 counters on this side. Okay, so that's there. And so here I have 2 unknowns. So I have an unknown amount in here, and then I'm going to draw a second one, an unknown amount in there. So 2n. So the one tip with this is whatever your numerical coefficient is, that's how many cups you're going to draw. So this is 2n equals 10 counters. So now as we know about equations, they are made up of 2 expressions that are equal in value. So on the right-hand side of this equation, I have a value of 10, which means because I have the equal sign, I have to have a value of 10 on this side. Now those 10 counters are evenly distributed between these 2 cups. There's no tricks here, they have to be evenly distributed. So if I'm going to take 10 counters and evenly distribute between 2 cups, there will be 5 counters inside of each cup. So 2 times 5 gives me 10. So this you would show n equals 5, 2 times 5 equals 10, 10 equals 10. Again, so I would take 5 of these, place them in that one, and 5 of these would be in this one. That's how we get that. Okay, let's try another one. So how about n plus 6 equals 12. Okay, so again, we've got this expression. The value here has to be 12 because the value over here is 12. So again, we would have 12 counters drawn here. So we've got 12 counters there. Over here, we have a known value of 6. So we can draw those 6 counters. And then my numerical coefficient here is just a single n, so there's a 1 there, so I had to draw 1 cup. So this 1 cup has an unknown amount of counters in it. And now we're going to figure out what they are. So there's 6 here. That if we were to get rid of those 6 and those 6 to make the value equal, we'd have to have 6 counters inside here. So n equals 6. So n plus 6 equals 12. So we're saying that 6 plus 6 equals 12. So 6 plus 6 equals 12. 6 plus 6 is 12. So 12 equals 12. All right, let's try another one. 6n equals, we're going to go with 18. 6n equals 18. Now again, we can do this one by inspection. We know that that n is 3, but that's okay. We're going to show it. So my numerical coefficient is 6, so I need 6 cups drawn. I like to draw the variable on them just to remind me of what they represent. All right, they're ugly, but that's okay. Equals 18. All right, so we've got 6 cups, or 6 variables here, and then we've got 18 on this side. So we have to have 18 distributed evenly between these. So we've got 6. One way you look at this, 1, 2, 3, 4, 5, 6. So there's evenly distributed. There's 3 in each of these. So in those. So n equals 3. 6 times 3 equals 18. 18 equals 18. Let's try another one. So again, whatever the formula is, whatever the equation is, we can draw that. 2 subtract n equals 12 subtract n equals 4. So we've got 12 subtract n, so it's just 1 cup. 12 subtract n equals 4. Okay, so I have 12. When I take away some, I get 4. So if I'm going to be left with 4. So how many I got to take away? Well, there's 4 on this top here. So I got to put those into that thing. So n is going to equal 8. 12 subtract 8 equals 4. 4 equals 4. That's modeling. Another way you'll see it sometimes is they will draw a balance scale. So they'll have a balance here. They will have a line across there. In the middle here represents equal because we have the balance. So it's balanced. That means the value or the weight on this side is the same as the value or the weight on this side. So we do the balance here. So that means whatever I have over here has to be over here. So when they show the unknowns, they might show some sort of container. Typically they have a X or an N on it. So that's our unknown. We don't have any inside the big box. So we'll say N. And then whatever they have, they'll have little boxes. These are the constants or like the counters. So this one, of course, is, let's make it 2. So this one has 2 n's, and then 1, 2, 3, 4, 5, plus 6 equals, so over here we've got 10 positives. So we've got 2n plus 6 equals 10. Okay, so again, each of these boxes, just like the cups, same thing here, they have to have the same amount in them. We won't do more in one and less in the other. Okay, so again, on this side, we've got 6 that we can see. So if I was to get rid of those, get rid of these 6, that shows how many left to be hidden somewhere. So we've got 4. So if we evenly distribute the 4 into the 2 boxes, you're gonna have 2 inside each box. So n is gonna equal 2. So that's how modeling to solve equations works.